Hi everyone, we have another episode of STEM Sundays with Emily coming at you right now. I hope you've had a great weekend and I hope you have a great week after this. So today's activity is inspired by the 20th anniversary of 9/11 that just happened this weekend. As an engineer, even though I design mostly bridges, I do have some educational background in the design of structures, especially buildings and skyscrapers. So I wanted to talk a little bit about some design that goes into buildings, especially skyscrapers, and help model two different types of design and structural engineering today with this activity. So we'll need just three materials: tape of any kind, paper, and toothpicks. So we're going to be using toothpicks to show the structural members, and our paper will be acting as our exterior facade. So this will be siding, concrete, whatever the building exterior looks like, and our toothpicks today are going to be modeling our structural members, either whether that's steel or concrete. Those are the two most popular types of structural members, and the tape we'll be using to tape the toothpicks onto our paper. So let's get started. And I just wanted to highlight these two main design types. So when we're designing buildings, again, I do mostly bridges, but in college and when I was starting to pursue a master's degree, I thought I wanted to move into building design. So I do have some background. I don't know a ton. I don't have any specific degrees in buildings specifically, but I just wanted to highlight two basic ideas that we're going to be modeling using these three materials today. So in terms of design, when we're building basic structures such as a house, small buildings that you might see generally in a small village, town, even in cities, there are still small buildings. Those are generally designed with the structural members inside, and then the exterior facade is usually some nice aesthetic, so you don't actually see the steel or concrete, or in terms of houses or residential, usually that's timber or wood. So that's all inside, all internal structural support. So you don't tend to see those on the exterior. But when we start designing skyscrapers and really, really large buildings, sometimes you can incorporate those structural members into the outside aesthetic. So that's called an exoskeleton. And if you are familiar with biology, and I think that's going to be our topic for next week, is diving into exoskeletons in terms of biology. But in terms of exoskeletons for structural engineering, that's when you're able to incorporate those structural members on the exterior. So it becomes part of the aesthetic and is becoming a bit more popular in modern design and technology to incorporate that into the exterior and to give the building or the structure a very modern appeal. So in the comments, in the description, I'm going to link some pictures so you can visualize what I'm talking about, but hopefully doing this activity too will help get a better picture of what we're talking about. So first, let's model what I think most of us are familiar with in terms of an internal skeleton structure. So let's get a piece of paper. I've got green. And I'm just going to start by folding it so that we can create a square or a rectangle. So most of the buildings that we see are usually some sort of rectangular or square frame, I guess is the best way to describe that. So you don't tend to normally have circular buildings, even though there definitely are those in the world, but generally I would say most structures are usually rectangular just because of the ease of construction. So that's why we're going to fold this paper today into, I think it might be a square, a perfect square, but if not, a rectangle for sure. I'm just going to recrease these lines so that we can fold it really nicely into our shape. So there we go. Alrighty. So now we have our square. If you remember our column activity, this is exactly how we started in the last time. So what we're going to do is move that out of the way. Okay, so now what we're going to do is pretend that we have our structure or building, whatever it is. We can say it's a school or a house or whatever it is. We're going to open it up. So here it is standing. We're going to lay it down and open it up and pretend that this is the interior of our building. So obviously buildings, or maybe not obviously, buildings are not usually built so that they just fold right up and you can stand them up. But for the activity today, I think that's an easy way to visualize the interior from the exterior in terms of design. So we're going to lay our structure down. And typically, when it comes to, if we want to focus on residential, just because that's easier, and I think most people can visualize that in their head, I'm just going to take out a few toothpicks, and we're going to start laying out the structural members. So for a residential structure, we're going to have members that run vertically and horizontally. So if you can imagine, think about your house. You have your walls, which are vertical, and those inside those walls are your structural members. So when we talk about being able to see them or not, this is a prime example of how you can't see the wood or the members inside of your house. But when we look at a skyscraper or a bigger building, sometimes you'll be able to see those members on the outside of the structure. So I'm just going to tape a few vertical members here. And again, think of these as walls. And a good way to also picture this in your head is maybe if you have some markers or a pen or something, pencil, maybe you can draw out so that you have maybe 3 different floors, and these are the walls of each floor. So now we're going to show our horizontal members, which is flat, and think of these as your floor, so your floor system. When you're walking around in your house or in your apartment, you're walking on either hardwood or carpet or some sort of material. Doesn't really matter what it is, but underneath that, in residential and really any structure, there are beams or members that create that floor system. So to be able to hold the weight of people walking around or furniture, all of that, there are members in your floor that you can't see again that are covered by some sort of nice aesthetic or some sort of fancy, nice material, and generally we're not seeing those members with our day-to-day eyes. So I'm just going to do one panel of this structure so that we can see the different types of members that go into this type of structure. So I have, at least in this example that I've created, we have our walls. Then we have our floor, say of our first floor, and then we're going to multi-purpose this toothpick here. That's going to be a member that would be the floor for your second story, but also the roof of your first story. So kind of a double acting member there. But again, if you are in a room in your house and you look up to your ceiling, generally, you're not going to be able to see those structural members. That might be the one place, though, that you will be most likely to see. I know sometimes in houses, generally in living rooms or other types of rooms in your house, you might be able to see rafters or some sort of wood beam that is exposed. But typically, if you can see those timber or wood beams in your house, those generally are structural, and not just for design or aesthetic purposes, but sometimes people like to add those in for aesthetics as well. So if you do have that component inside of your house, maybe ask your parents and see if they know if it's structural or just for good looks for design purposes. So I'm just going to put 2 more toothpicks so that we can finish our framing of this structure. One more wall and our ceiling for the top story. All right, perfect. So here we have our full framing system, walls, floor, ceiling for each story. So typically in residential or small buildings, all of this will be hidden from the outside. so you won't be able to see that from the exterior of the building most of the time. In our smaller residential or smaller structural structures, I guess I should say, smaller structures, those structural members are hidden, but they are internal and they do exist. They're just not visible to the eye. But now, if we take this and we fold our creases the other way, one more, and we fold it this way, you can see that now our structural members are exposed. And if you're walking down the street and you look up at this building, in this scenario, you would be able to see the structural members because they're incorporated into the exoskeleton structure of the building, whatever it may be. So typically for larger scale structures, looking at skyscrapers in particular, and again, reference some of the pictures down in the description there, but you'll see that these structural members might not be laid out typically this way because these structures are so big, but you will be able to see massive members that are used to hold up the weight and to get the capacity for the loads going into that building. So this is an easy way to see if it's an exoskeleton design structure, and then again, if we were to fold it in on itself, that becomes an internal structure and you don't see those structural members from the outside. So I hope that teaches you guys a little bit about exoskeleton design versus internal. And next week, I think it would be fun to talk about exoskeletons in terms of biology because that is really important too. Spoiler alert, we don't have exoskeletons as humans, but there are animals and other creatures that exist in the world that do have exoskeletons, and there are pros and cons to both. So I hope you had fun learning about exoskeletons as it relates to structural engineering, one of my favorites. But tune in next week and we'll talk about the biological component. So have a great week, and I'll see you next week. Bye, everyone.